Hi guys, this is Mrs. Denton. I'm going to be doing Algebra Lesson 1-3 today, solving simple equations. So if you want to get your notebook paper and label it Lesson 1-3, solving simple equations. We're going to start with these 6 warm-ups that say simplify the expression. There are mixed operations. There are positive and negative integers, and you can pause the video to give yourself time to solve these, and then we'll check your answers. Okay, looking at number 1, we have 5 plus negative 15. You can put that directly into the calculator, just as you normally would. Or you can think about your integer rules. When you're adding different signs, you take the sign of the greater numerical value and you find the difference. And the difference between 5 and 15 is 10, making that a negative 10. Number 2 has 6 subtract 7. Again, you can put that directly into your calculator. Or you can recall your integer rules with subtraction. You really don't subtract, you add the opposite. And then you go back to that rule that we looked at on number 1. Take the sign of the greater numerical value and find the difference, giving us negative 1. Number 3, 10 times negative 1. When you're multiplying different signs, you get a negative value. So negative 10. Number 4, multiplication and division. You have different signs, making this a negative. And 30 divided into groups of 2 is 15. So we have negative 15. Number 5, negative 1 times 0, anything times 0 equals 0. Number 6, 4 subtract negative 5. Again, we never subtract, we add the opposite, making both of these positive, which equals positive 9. Now we've got some vocab. We have equation, and an equation is a statement that two expressions are equal. So we're going to be working with the equal sign. If you'll remember last week when we were talking about expressions, we talked about not having an equal sign. So again, an equation is a statement that two expressions are equal. Next, we have a linear equation. Linear equation is an equation that can be written in the form ax plus b equals 0, where a and b are constants and a cannot equal 0. Our next vocab is solution. And solution is one of those words that you've probably heard before. A solution is a value that makes an equation true. So basically we could say the answer to an equation. Inverse operations. Inverse operations are two operations that undo each other, such as addition and subtraction, multiplication and division. If you square a number, you can undo that operation by taking the square root of that number. Equivalent equations. Equivalent is just like the word equivalent. Equations that have the same solution, or solutions in the plural context. Okay, now we have some properties. We have the addition property of equality, which states when adding the same number to each side of an equation, we will produce an equivalent equation. So if I know that A equals B, then if I added C to A and added C to B, those equations would remain equivalent. The subtraction property of equality states that I can subtract the same number to each side of an equation and produce an equivalent equation. So once again, if I know A equals B and I subtract C from A and C from B, those equations remain equivalent. Example 1. Solve each equation, justify each step, check your answer. We are going to justify each step by showing our work, showing the steps that we're taking to solve each of these equations. Look at example A with me. X subtract 3 equals -5. Now, with an equation, we can think of the equal sign as our divider. Everything to the left is one side, everything to the right is one side. When I'm working with an equation, I always start on the side with the variable. In this case, it's the left side because we're working with x. Now, on that left side, I notice that I have the operation subtract 3. Or you can look at it like a -3. If I want to undo that or use the inverse operation, I'm going to add 3. Essentially, I'm trying to cancel out or make a zero pair. Whatever I do on one side of the equation, I must do on the other side of the equation in order to keep it balanced. -3 plus 3 equals 0, leaving me with an x on this side. I'm going to bring down my equal sign, and if I do the math on the right side, I have -5 plus 3, which simplifies to -2. Now I'm going to check my answer. So if I were to take this solution and substitute it into the original equation in place of x, I have -2 subtract 3 equals -5. So if I put that in my calculator, if I do the math, it doesn't matter. I end up with -5 equals -5, which does check out as my solution. So I know that x equals -2. For example B, again, I'm going to think about this like a divider, where I have my left side and my right side. My variable this time is on my right side, y plus 2 8/10. That's the side I'm going to start with. They're adding 2 8/10, so in order to undo that, I'm going to use the subtraction property of inequality, and I'm going to subtract 2 8/10. Now, whatever I do on one side, I must do on the other side. So I'm going to subtract 2 8/10 on the left side as well. That allows me to make a zero pair or cancel out. I can then bring my y down, bring my equal sign, and put 9/10, subtract 2 8/10 into your calculator. Please don't reverse those. We're subtracting from 9/10, and when I enter that in my calculator, that's the order that I need to have. I get -1 9/10 equals y. Now we're going to check that in the original equation. So I'm going to write my original equation, 9/10 equals And I'm going to substitute 1 and 9/10 in place of y plus 2 and 8/10. And again, I can put that directly into my calculator. And I'm verifying that this side is the same as the other side, 9/10. So once I check that out, I know that my solution is y equals -1 and 9/10. Okay, we have a couple more properties now before we go on. We have the multiplication property of equality, which states multiplying each side of an equation by the same non-zero number produces an equivalent equation. So if I know once again that a equals b, and I multiply a times c and b times c, as long as c does not equal 0, these equations will remain equivalent. The division property of equality states that when dividing each side of an equation by the same non-zero number, we will produce an equivalent equation. So again, if a equals b, and I divide a by c, and I divide b by c, and c does not equal 0, those two equations remain equivalent. Now we're going to practice those two properties, the multiplication property and division property of equality. Our directions in example 2 say solve each equation, justify each step, check your answer. Example A, -n divided by 5 equals -3. Now I can move this negative sign with the numerator or the denominator. I prefer to put it with the number value, so if I want to think about this like -5, then I can get rid of it when I do my multiplication property of equality step. So they're dividing in by -5. In order to solve that, I'm going to undo the division by multiplication. So I am going to multiply both sides by -5. Now, when I multiply this fraction by -5, I can actually simplify the 5's. And if that's confusing, if you will recall back in 6th grade math, when you are multiplying a whole number by a fraction, you can turn that whole number into a fraction by putting it over 1. And before you multiply straight across, you can simplify those values that have common factors. For example, -5 is divisible by -5. How many times does it go in there? Once. So all of this simplifies to 1n over 1, which simplifies to n. So this entire left side simplifies to n. Bring down my equal sign and simplify my right side. -3 times -5 gives me a positive 15. Now, if we want to check that, we're going to substitute that into the original equation. So 15 in place of n divided by -5 equals -3. And we can put that into the calculator if we need to and verify that -3 does equal -3. So I have a solution of n equals 15. Okay, let's look at B. On part B, we have pi times x equals -2 pi. Now, again, let's think about our divider as our equal sign. if we don't really know where to start on a problem like this, our variable is on the left side. So we're actually solving for x. Now pi and x are being multiplied. They're side by side, so it's understood to be multiplication. If I want to isolate or get x by itself, I'm going to reverse the multiplication, or basically use the inverse operation and divide by pi. And whatever I do on the left side, I must do on the right side as well. So this simplifies to 1, leaving me with x. Bring down my equal sign. Over here I simplify this, and I'm left with negative 2 times 1, which is simply negative 2. Now let's verify if we're unsure if this is the correct solution. So I'm going to take my original equation where I have the pi and I have x, and I'm going to substitute the negative 2 in place of x equals negative 2 pi. Now, if I went ahead and switched the order of that, I would have negative 2 pi, which is how it should be written with your number as the coefficient, equals negative 2 pi. So I just verified that yes, that was correct. So my solution for example B is x equals negative 2. Okay, let's start out with example C. 1 3/10 times z equals 5 2/10. So here's my divider. My variable's the z. It's being multiplied by 1 3/10. So I'm going to divide or use the inverse operation. Whatever I do on one side, I must do on the other. Simplifies to 1z or z. And I can put this directly into my calculator. 5 2/10 divided by 1 3/10. And that's actually going to simplify to 4. Now, if we want to check that, we're going to go back to our original equation where we have 1 3/10 times z, which we determined was 4. And we're going to see if that's equivalent to 5 2/10. So put that into your calculator, and we can verify that 5 2/10 is, yes, equal to 5 2/10. So z equals 4 is my solution. And these are examples using the multiplication and division property of equality. Okay, now we're going to take a 4-step approach to problem solving. And this is a strategy for word problems. Number 1 says, understand the problem. What is the unknown? What information is being given? What is being asked? Basically, what are you trying to find? Number 2, make a plan. This plan might involve one or more of the problem-solving strategies shown on the next page. Number 3, solve the problem. Go ahead and carry out your plan. Check that each step is correct. And number 4, look back. Examine your solution. Check that your solution makes sense in the original statement of the problem. Ask yourself, is this a reasonable answer? Example 3. In the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19 and 32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. Now we can go back to those strategies on the previous page. And let's look at number 1. Understand the problem. What is the unknown? What's being asked? Okay, so it says write and solve an equation to find his average speed. So we are trying to find his average speed. That's the unknown. Number 2 says make a plan. This plan might involve one or more problem-solving strategies shown on the next page. Now, when we talk about make a plan, we are stating decide what you want to determine and how to go about it. Our directions tell us to write and solve an equation. Now, there's some things that we already know here. We know that it was a 200-meter dash, so we know the distance. We know he had a time of 19 and 3200 seconds. What we don't know is his speed. So there's our unknown. Now we have a formula in math called the distance formula, and you will also use this in science as well. So distance formula, and my pen is horrible right now. So in the distance formula, we know that D equals R times T. Now in this situation, D is our distance, R is our rate or speed, and T is our time. So if we were to use these and substitute each one of these in place, our D or distance is 200 meters. Our R or rate of speed is our unknown. And our time is 19.32. So once we have those, then we can substitute those into the formula. So we're going to take what we know and we're going to replace our D and our T to solve for R. So we have 200 equals, and we're going to take R times 19.32. Now, when we go about solving this, there's multiplication going on with our variable. So we're simply going to undo the multiplication by division. Whatever I do to one side, I must do to the other side. So I'm going to plug into my calculator 200 divided by 19 and 3200ths. And once I have that set up, our directions say to round or find to the nearest hundredth. So you can see in our calculator, we're going to round it off to that second place behind the decimal. So we can say 10 and 35 hundredths. Now if we round anything off, it's no longer equivalent. It is now approximate. So approximately R. So if I wanted to turn this into a statement in order to answer the question in that context, I'm going to say Bolt's average, and I am just simply taking the question or the statement that's telling you what to find and restating it into another sentence. So Bolt's average speed was about 10 and 35 hundredths meters. We're going to include our unit, meters per second. So look at the strategies, look at what we did. We marked up our word problem, we come up with a plan, we used the distance formula, and we substituted and solved using those properties of equality. Okay, some more common problem-solving strategies, and some of these are probably familiar. Use a verbal model, verbal meaning in words. Draw a diagram. Pictures always help. If you're a visual person, that would definitely help. Write an equation. That's what we did in the previous example. Look for a pattern. Some people can notice a pattern very quickly. Work backward. If you know the answer but you're being asked to write an equation, use that answer to help you arrive at an equation. Guess, check, and revise. That's actually a strategy and you can use it. Sketch a graph or number line. That's always easy to do. Make a table. Make a list. Both of those organize your thoughts and processes and steps. Break the problem into parts. Make it easier to solve. Okay, example 4 says, on January 22nd, 1943, the temperature in Spearfish, South Dakota, fell from 54 degrees Fahrenheit at 9 a.m. to negative 4 degrees Fahrenheit at 9:27 a.m. How many degrees did the temperature fall? Now, let's think about what we have here. The date, no, not important. Temperature, definitely. We have a 54 degrees Fahrenheit, and we have a negative 4 degrees Fahrenheit. We also have the 54 recorded at 9 a.m. and the negative 4 at 9:27 a.m. What's being asked? How many degrees did the temperature fall? So we've got an unknown there. We want to know how many degrees the temperature fell. Now I'm going to set my unknown as a capital T so it doesn't look like a plus sign. And we're going to say our unknown is the number of degrees the temp fell. So that's what we're going for here. Now, I do know the temp at 9:27, the temp at 9 a.m. What I do not know is the number of the degrees fell. So we ended up at 9:27 is later than 9 a.m. So this is where we ended up at. This is what I'm going to set as an equivalent. So the temp at 9:27 is equivalent to the temp at 9 a.m. minus the change, or the number of degrees temp fell, which is also going to be my variable T. So if I ended up at negative 4 degrees and I started at 54 degrees and I subtract that number of degrees that the temp fell, which is unknown, I've got an equation that I can solve here. Now to solve this equation, I'm going to start out by using my variable, which is the T on the right side, and I've got a 54 that I want to move or get rid of. The opposite of a positive 54, remember, is a negative 54, and negative and subtraction is the same thing. So if I subtract 54 from one side, I must subtract 54 from the other side. Now if I go ahead and do this math, I get negative 58. Bring down my equal sign. Now this is something that we need to be watching for. If there's a sign in front of my variable, it must come with it. So if it's a negative or subtraction sign, I'm bringing it down to my solution. I cannot have a solution where my variable is a negative. So I'm definitely going to have to work around that. Now you might see some people just take away both of the negative signs and say t equals 58. And that is correct. I want to show you why that's correct. If I put a coefficient in front of my t, because it's understood to have a 1 actually, I now have negative 1t. If I want to isolate my variable t, I can divide both sides by a negative 1 so that I'm keeping up with that division property of equality. I cancel out the negative 1 or get rid of it or simplify it. And over here, when I go to do the math on the left side, I have negative 58 divided by negative 1, which simplifies to positive 58 equals t. So now I'm going to ask myself, does that seem like a reasonable or logical answer? If you think about a thermostat, which measures the temperature, and you go on the opposite side of the 0, you could actually have a change of 58 degrees because you have to account for both the positive and the negative side there. So we are now going to simplify this. What does t equals 58 or 58 equals t mean in context of this problem? It means the temp, and again we're just going to restate the question, the temp fell 58 degrees Fahrenheit. So basically we're restating what t is equivalent to and what it means in context of this problem.